Hi everybody, today we're talking about shapes of distributions. We've already talked about measures of center, mean, median, and mode, but we can also describe a data set talking about its shape. There are three main shapes that we will talk about in this unit: skewed left, symmetric, or skewed right. Now I have histograms all drawn here, but we can find the shape of any distributions. Let's first start with symmetric. Now, symmetric, we think of mirrors. So in this case, we're saying our data set is symmetrical about the mean if whatever is on one side is mirrored on the other side. How I can decide this is that I go one interval out. What are the frequencies in those intervals, or what's the height of those bars? They look the same. As I go two intervals out, these two also have the same frequency or the height. How about three intervals out? Again, same frequencies or same height. We can also think about it in terms of folding. So if I took everything on this side and folded it to the other side, whatever's on one side is also on the other side. Now, sometimes things aren't always perfectly symmetrical, but they're almost symmetrical. And if they're almost symmetrical, we call it roughly symmetric. Now, if it's clear that it's really not symmetric, we have another option: skewed left. Skewed left, as you can see from the diagram there, that histogram skewed left because the tail is to the left. It's also like I just took the tail and I pulled it to the left. If I'm pulling my data to the left, I'm skewed left. This over here, by contrast, would be like taking my data and pulling it to the right. It's skewed right. The tail is on the right. Even though most of the data is on the left, the tail and where I'm pulling my data is on the right, so this is skewed right. Let's try two examples. Example 1 right there gives you the daily snowfall amounts. I can see what I did first there is I just drew a nice smooth curve over it so I can see. Now what it looks like is that on the right I'm taking the tail and pulling it to the right. Since I'm taking the tail and pulling it to the right, or since the tail is extending on the right, that's skewed left, skewed right. Most of the data is on the left. Maybe that would also help me to see that that is skewed right. I want you to try B on your own. Let's skip to C. Again, my first step was I drew this smooth curve over. What I see is that a lot of my data is on the right, but my tail in the long end of my smooth curve is going to the left. So I'm taking it and I'm pulling my data to the left. This is skewed left. They're both not symmetric because we don't see that mirror image, same on both sides, both tails extending. Let's try the next example. Here is example number 2. Example number 2 gives you ages and frequencies of different moviegoers of a comedy movie. I first went ahead and drew my histogram. I want you all to do this too. It's really nice because they gave you the intervals to use. So I know that I start with the intervals from ages 10 to 13, 14 to 17, and so on until I go all the way up to 34 to 37. I see that my biggest two intervals are these right here. It's 26 to 29, I had 20 people watch. In 30 to 33, I had 18 people watch. Once you've drawn this, our next step is to describe the shape of the distribution. So let's go ahead and draw our smooth curve over. So I might draw a dotted line just so I can see it this time. So I'm just going to draw right around the corners. And what I see here is that most of my data is on my right, but this tail is being pulled this direction. I would call this right here my tail. Since my tail is being pulled to the left, I can say that this distribution is skewed left. It's not symmetric because, first off, the middle point's pretty far to the right, and also I don't see any mirroring happen. Let's try the last example. Example number 3 says first we have to describe the shape of that animated movie. Now if I were to draw a curve over it, we can see this time it's being pulled to the right, So this is skewed right. Now they ask us which movie do we think has the older audience, animated or comedy. I went ahead and just copied the comedy graph right here so we could see. Let's take a look at this. This data set was skewed left, which means most of my data is on the right. This was skewed right, which means most of my data is on the left. In this case, I have the largest frequencies on the smallest values. I have the largest frequencies on the larger values here. So I can see that more of my data is on the older ages, more of my data is on the younger ages, so that means that comedy, in this case, has the older audience.